Hi lads, this morning I'm focusing on distance speed time graphs. I'm looking at the distance speed time formula as well. We're going to dive straight into this question here. Just be aware I'm not looking at timetables. If you do need help with looking at timetables, then send me a message and we'll see if there's an interest in that. However, I think the main things we can focus on here are things that come up all the time, which are graphs and formulas. So look at this question here. Grania is taking part in a training session. Okay, we're told the graph shows the distance you travel during the session. The four parts of the graph are labeled A, B, C, and D. Okay, I've already done a little bit of labeling on this graph for you. So we can see here distances on the y-axis. So as distance increases, it goes up. Okay, as time increases, it goes to the right. Now, of course, time is always moving, so this axis here will continue on forever, okay, because time, of course, is always moving. It's a good idea before you even go and read the questions to make sense of this graph you have in front of you, okay? So what we have here in front of us here is a situation where her journey varies, okay? At point D and B are kind of significant because we have a horizontal line. And that means that distance is neither increasing or decreasing. So therefore, I put in brackets above it, not moving. For B, it's the same, she's not moving. Now, that's kind of half the graph kind of figured out already. And we now need to look at A and C. If we look at A, we can see, okay, A means that distance is increasing, but it's only increasing slightly, okay? So you could label that and say increasing slightly. And what we mean is increasing slightly is the distance, okay? So she's not really moving very much, but so she is moving. If we look from the end of B until D, or in other words C, we can see here that we can see that the distance is increasing and it's increasing a large amount, okay? So increasing. So probably what's happening here is if it's increasing a large amount, I would say here that she's probably running, okay? In this case, and that would make sense because we have a very steep line. What we have to do here is we have to write the letters A, B, C, and D into the table to match to each description with the correct part of the graph. And this should be pretty easy now if we look at our labels that we have in this graph already. Let's look here at the ones where Grania has stopped. We have two options where she stopped. She stopped here on D and she stopped here on B. But we need to figure out the timescales now. If we look here, 35 minutes, 50 minutes. So what's the difference between 35 and 50? There's a difference of 15 minutes here. So therefore, the correct answer for Grania stops for 15 minutes is going to be D. Grania stops for 5 minutes. We can see there's a difference here of 5 minutes here between 10 and 15. So therefore, the answer for that is going to be B. That means we've now done 50% of the labeling. Running for 20 minutes, walking for 10 minutes. And if you look at the time scales just to confirm, I think we've kind of figured it out already, but look at the time scales. 0 to 10, that's definitely 10 minutes. So I would say A, and that makes sense because we said, look, the line is increasing slightly. It's not a massive amount, so we can see here that Grania is walking. And finally then for 20 minutes, we can see here 15 until 35, that is 20 minutes, so therefore C is part of the graph there. So that is all of our labeling done. We've now answered part A. We now need to answer part B. Okay, so in this question here, it says Grania runs 4 kilometers in 20 minutes at a steady pace. Find her speed in kilometers per hour. I think this unit here is significant. We want kilometers per hour. So we're looking for speed is an unknown and it's in kilometers per hour. If I notice here, I definitely have Grania runs 4 kilometers, so that's a distance. So distance equals 4 kilometers. I know time is equal to 20 minutes. Now I can do a conversion on this. I think I have to do a conversion on this because we need to get it into hours. Okay, so what would time as 20 minutes be in hours? But if you think about it, 20 minutes is only a fraction of an hour. 20 out of how many minutes there are in an hour, which is 60. So time is equal to 20 over 60. Therefore, if we do a bit of simplifying on this, we could divide 10 into the top, 10 into the bottom. We have 2 over 6. And 2 goes into 2 once, 2 goes into 6, 3. So therefore you end up with a fraction of 1/3 of an hour. Okay, so time equals 1/3 of an hour. Now just beware, fractions are a little bit awkward. We don't like fractions in this section. We prefer decimals because we're going to have to use the calculator for some of these calculations. So let's change this to a decimal. Now, if you work this out in your decimal or your calculator, you would get time equals 0.3333, and this is just going to continue on like that. Okay, so we've got the time now in the correct format. This is in hours, and we have distance. We now need to figure out how do we use them together. Now you have a few options here. You can just remember that speed equals distance over time. In other words, distance traveled in a given time. Or you can just use your triangle. Okay, so Dad's silly triangle, or deadly session tonight. D on top, S and T on the bottom. So let's substitute in what we know because we want to find speed. Speed equals, in this question, 4 kilometers divided by time. In this question, it is 0.3333 hours. Now there's probably a few more threes, but we just need to add enough decimal places that will get the most important numbers here when we do this calculation. Okay, so this is where you want to use your calculator. Okay, so we look at this one, we have 4 divided by 0.3333, get equal to sign. Now I end up with a weird number on the calculator here, but what I need to do here is I need to press SROD, and I'm getting a value here for speed, which is 12.0012. Okay, don't forget your units. We have kilometers per hour. Now, I might want to round it up because that's kind of a weird value there. So it's 12 kilometers per hour. At the end of the question, ask yourself, does that value make sense? So for this one, does it make sense that we would have 12 kilometers per hour? It seems kind of reasonable. If you think about a car traveling, we'll say along a main road, it might go 100 kilometers an hour, and this girl here, Groney, is able to run at 12 kilometers an hour, so that kind of makes sense. If you end up with something nuts like 200 or maybe even like 0.1 kilometers per hour, that would definitely not make sense. So therefore, you need to go over your question again. Okay, so that is that question there. A few steps you had to take on that one. You had to do the conversion. So if you look at it, we had to do a time conversion. So we had to convert between minutes and hours. Now, normally we need to get it in hours. That's kind of the standard. So just beware of that. Beware if you see it in minutes. We had to use the formula. Okay, use formula. So I suggest learn off maybe Dad's silly triangle. Okay, or just remember the formula. Okay, that leads us on to the next question here, which is going to be focusing on conversions. So we are told here that we have a helicopter leaving Shannon at 9:30 a.m. and arrives in Limerick at 9:45. Find the mean speed on the journey. Okay, so what we need to do here is underline the key information. We're leaving Shannon at 9:30, we're arriving at 9:45, so therefore the time or the duration of the journey is, well, if 9:45 and 9:30, so therefore we have 15 minutes is how long this journey took. Now remember what we said previously, normally we want that in hours, and let's see if that's the case for this one. It says find the mean speed on the journey in kilometers per hour, so definitely we want to find speed, and it has to be in kilometers per hour. So I'm going to have to convert this one again. again, remember, minutes, if you think about it, they are fractions of hours. So that's 15 out of how many minutes there are in an hour, which is 60. So I have 15 out of 60 in terms of hours. But sure, that would be a quarter of an hour. Or as a decimal, it would be 0.25 hours. Again, you could use your calculator on that to get the value there. Okay, so in each of these cases here, I know that this is time. In this question, we're also told distance. So a helicopter leaves Shannon, it arrives in Limerick the same morning, it travels 25 kilometers during the journey. So distance equals 25 kilometers. Time is 0.25 hours. So what we could do again is write in our formula, speed equals distance over time. Okay, speed equals distance, 25 kilometers, over time, 0.25 hours. Again, you want to use your calculator. So for this, we have 25 divided by 0.25. We're getting a value there of 100. Okay, so therefore, speed equals 100. Speed, what are its units? Kilometers per hour. Okay, so you got a nice even value there for that one. Now, please be aware on this section, you always pick up marks for the following. Your formula. Substituting into your formula. Okay, so substituting in. And I suppose if you jump from the start of the question to a final answer and get it wrong, you'll get no marks, but you will always get attempt marks here for things like conversions. Okay, so please show your workings on your exam in June. Next question. We want to look at one other type of question. The difficulty level is a little bit harder on this one. Okay, but I know you're well up for this one. So we're told here a car travels at an average speed of 90 kilometers per hour. So therefore speed, we can write down that the speed is equal to 90 kilometers per hour. We're asked in part A, how long would this train take to travel 210 kilometers? So how long will this train take? Really, if you think about it, what we're being asked for there is time. Okay, so we don't know how long it's going to take for this train to get from A to B. We do know the distance it has to cover though. It has to cover 210 kilometers. Okay, and that information is available there. So I'm asked to work out time. Now this is where your triangle comes in handy. Okay, remember Dad's silly triangle. Okay, so I don't know the time. I want to work out time. If we cover up the t there, we get d over s. Okay, and that would be how I work out what time is worth. You could do that the slower way. You can go distance equals speed over time. You could use algebra, okay, to get it to isolate the part that you want, which is the t. So t times d equals s. T equals s divided by d. Okay, I made a mistake there somewhere. Speed equals distance over time. So we have speed times time equals d. Time equals distance divided by speed. Okay, so I think this one here is much easier. Just use your triangle. Okay, cover up what you don't know. Time equals distance divided by speed. And you get the same answer this way, but it's just a little bit more long-winded. Okay, so let's go back to this original formula. T equals 210 kilometers divided by 90 kilometers per hour. Use your calculator on that one. So we have 210, we have divided by 90 equals 7 over 3, or getting a value there of 2.3 hours. Okay, and that's the value for that one. Part B then, if we look at it, so part B, how far could this train travel between 1350 and 1540? Now again, it's good to isolate the information. So we have another journey now. 1350 is when we started the journey, and we finish the journey at 1540. We want to work out the duration of time there first of all. Okay, so duration of time for that one. Well, this is where, when you're doing a time calculation, it's a good idea to use your calculator. So we 1540 minus 1350. Now, there's a button on your calculator which is designed to deal with this, okay? And that is this button here. So you're telling the calculator here what the time, that this is a time calculation by clicking this button. 15, you click the button. 40, you click the button. Minus 13, click the button. 50, click the button, equals. I know put a weird value here in the calculator, but actually it makes perfect sense. This means 1 hour and it means 50 minutes. It means 0 seconds. Okay, so we have 1 hour, 50 minutes. That's the duration of the journey there. Now, remember, minutes, we don't want that. We want to change that, so 50, again, is a fraction of an hour, 50 over 60. That's 5 over 6, or on your calculator, 50 divided by 60, SROD. I'm getting a value there, which is 0.83 of an hour. Okay, so therefore the duration of time in this case is 1 hour plus 0.83, so that's 1.83 hours. Okay, do you see that? So what I did was, we started the journey at 1350, finished at 1540, so therefore I subtract 1350 from 1540. I use my calculator to do that. I got 1 hour, 50 minutes. I didn't want the minutes in the form they are. I want it as a decimal, so therefore I divide 50 by 60 to get it into a decimal, 0.83 of an hour. I added that on to the original, which was 1 hour, so 1.83 hours. So go back to the question. How far would this train travel between 1350 and 1540? How far means distance. So distance is unknown. Speed, I think, actually is known. If you go back to the original part, it says a car travels at an average speed of 90 kilometers per hour. 90 kilometers per hour. And time, we've just figured it out, is 0.83 hours. So therefore the calculation for this, again, you use your triangle. We have DST. What do I know? Time and speed. What don't I know? Distance. So therefore distance equals speed by time. Distance equals 90 kilometers per hour multiplied by 0.383 hours. Again, you use your calculator for this. So we have 90 multiplied by 0.83 and I get a value. Again, I don't want it as a fraction. I do want it as a decimal. 74.7 is what I'm getting for that. So 74.7 and distance kilometers. Okay. Made a mistake there. 1.83. So go back to that. It was 1.83 hours. 90 multiplied by 1.83 equals SROD 164.7 kilometers. Okay, so that is distance, speed, time. Have a go at the questions, see if you can do them, let me know.